All right, so I want to do a couple more examples of multiplying and dividing rational expressions. I'll do one more division example and another multiplication example. But remember, they're really very similar. The only difference is that with division, we have to start by realizing that we're multiplying by the reciprocal. So that's the only difference. Everything else stays the same. Okay, so here we have a division problem, as indicated by the division sign. So that means we need to keep, change, and flip. So we keep our first expression the same, 9x divided by x to the third plus 6x squared. Change the division to multiplication, that's our C, and then flip the second expression. So our second expression will be x squared plus x minus 30 over x squared minus 25. Okay, and now we just do multiplication, which is just, remember, pretending that there's no line or that there's no separator. We just pretend like this is one big line and that everything is in parentheses. But before we kind of put it all together like that, we need to factor whatever things we're able to factor. So we can't factor 9x. I guess we could write it as 3 times 3 times x. But for now, let's just leave it as 9x. What about x cubed plus 6x squared, our denominator down here? That we can factor, right? Because they both have at least two x's, right? So we can pull out a GCF of x squared, and we're left with x plus 6. So we pulled out x squared, we're left with x plus 6. For now, let's just keep this multiplication sign here. I guess we're not pretending because it is actually there. But let's not get rid of it just yet until we're done factoring everything. So now we've got x squared plus x minus 30. If we want to factor something like that, remember we set up our table. So we'll set up our what adds up to be 1 and multiplies to be negative 30. Sorry, I did that wrong. That's not how we do that. Oops, now we're jumping all over the place. Let's see. Okay, so we're looking for what adds to be 1 and multiplies to be negative 30. So it should be 6 minus 5 is 1, right? And 6 times negative 5 is negative 30. Again, if you're struggling to come up with those, we'll list out the factors of 30 and then see in what combination of those you can add or subtract them to get 1. Okay, so that makes this factor out to be x plus 6 times x minus 5. And then down here we have a difference of squares, x squared minus 25. So those are both perfect squares. So remember, x squared, so we take the square root of x squared, which is x, and we take the square root of 25, which is 5. And remember, we can do that because it's a difference of squares. It's being subtracted. We couldn't do this if it was addition. And so then we pull those together to get x plus 5 times x minus 5. So that's how that simplifies. And if you don't remember that, go back and watch one of the other videos where I clarified how to do difference of squares. But that's the basic idea. So that factors out to be x plus 5 times x minus 5. Okay, so now we factored everything that really we can factor. We could still, like I said, we could still factor that 9x if we wanted to, but it's not going to help us. We could do 3 times 3 times x, and then that x squared is really x times x. But again, In this case, nothing's going to cancel out with those, so it doesn't matter. We don't need to do that. So now we can go back and get rid of this multiplication and say, okay, this is just one big line where everything's in parentheses. So what can we cancel out? Well, we've got an x plus 6 on the top and on the bottom. We also have an x minus 5 on the top and on the bottom. So, and that's all we can cancel out. There's nothing left to cancel out. So then our final answer based on that becomes, well, all we're left with on top is 9x, and all we're left with on bottom is x squared times x plus 5. And that is our final answer. We canceled out everything we could. We did the division, and that's our final answer. Okay, let's look at another example. This time just multiplication, not division. So we don't have to start with this keep, change, flip thing. We don't have to do anything because this is just multiplication already. So we start with step 2, really, and we just go straight to factoring everything. So remember, this is a difference of squares right here. X squared minus 9. So we take the square root of x squared is x, and we take the square root of 9, which is 3, and that will become x plus 3 times x minus 3. So x plus 3 times x minus 3 becomes that numerator. Down here, we're looking for what, let's do this in a different color. Down here, we're looking for two numbers that add to be negative 3 and multiply to be negative 18. So again, if you're struggling to think of two numbers, just list out the factors of 18. So if let's just do that really quick, just to kind of walk you through that. We got 1 times 18. There's no way that I can put those two numbers together to get negative 3. It's because for that to work, they need to be 3 numbers apart. And 1 and 18 are 17 numbers apart, so that doesn't work. So I think of the next one, okay, how about 2 and 9? 2 and 9 are 7 numbers apart, so that's never in any form going to give me 3. Okay, so then how about 3 and 6? Okay, those are 3 numbers apart. 3, 4, 5, 6. Those are 3 numbers apart. So in some form, those can give me negative 3. The only way for those to give me negative 3 is to do either negative 6 plus 3, right? Or 3 minus 6, either way, same thing. So that's right, negative 6 plus 3. And negative 6 times 3, those give me the numbers I'm looking for. Those add together to be negative 3, and they multiply together to be negative 18. So then that becomes x minus 6 times x plus 3. Okay. So we're doing multiplication. We're going to leave that there for now. We know eventually we'll get rid of that sign, but we'll keep it there for now. 5x to the third, I'm not going to factor that right now because there's nothing here that looks like it's going to cancel with that. I could write it as 1 times 5 times x times x times x, but I don't need to because it's not going to help me. So, and as you get more comfortable with these problems, you'll realize when you need to factor and when it's not really all that necessary. So right there, it just wasn't. But I should factor this bottom part, 2x minus 6. 2x minus 6. I can pull a 2 out. It's a GCF of 2. So remember, if it's a binomial or only 2 terms like that, I don't do my chart. I don't look for addition and multiplication. That's like I did in green here. I don't do that. And this isn't like in the blue where I have a difference of squares. So the first thing to remember when I'm factoring is I want to look for a GCF, a greatest common factor. And these share a factor of 2. So I can pull that 2 out, and I'm left with x minus 3. Excuse me. Okay, so I factored everything. So now remember again, I can just pretend This is all one big fraction, and put everything in parentheses, and just see what cancels out. So, well, I've got an x plus 3 on the top and on the bottom, and I have an x minus 3 on the top and on the bottom, and that's all that I see. I can't even simplify, for example, 5 over 2. Like, that doesn't simplify. If it did, I could, but it doesn't. 5 is a prime number, 2 is a prime number. There's nothing to simplify there. So on the top, I'm just left with 5x to the third, and on the bottom, I'm left with 2, right? The 2 and the x minus 6. And again, it doesn't matter. I could have wrote x minus 6 and put 2 after it. I just like my numbers out front. So that's our simplified answer for this problem. So that's just a quick review. I'll kind of zoom out and give you a full, well, maybe I will. It's kind of far, maybe difficult to see. But just multiplication and division of rational functions.